share screen. So like we have said before, um, so you have 6 labs, 6 labs. So now we are in the third lab, which this one, lab basic hydraulic. So don't confuse about this arrangement. This is like the normal arrangement when we go to the lab. So normally before this they assign weight seats to brief to the students for all of these labs, 3, 4, 5, 6. Maybe briefing to the components, show the components, show the labs, and how you can connect the components, everything. But because we are doing the online, so I'm not doing this briefing session. So we just go straight to the lab, so that we can go through one by one, the 3, like 4, 5, and 6. So today we are in this lab 3, and you should submit your report, all of these 3, 4, 5, 6 by 21st January 2021, not 2023. So we have complete lab 1 and 2. Hopefully all of you and by group has maybe in progress or whatever. Hopefully you can compile and submit by this deadline. Like I said, I will not tolerate any excuse, whatever excuse we will not tolerate, because we already have mentioned this very early. You should plan how you can complete and compile and submit the lab report, unless you came to us and mention whatever problem you got. Maybe that we can consider, but we will not tolerate any submitted beyond the deadline. Okay, so that's just okay. So so from in the classroom, I have posted this lab sheet, lab 3. Okay, so like usual, you have your names, write your names, everything. So for today's lab, or the objective for this lab 3 is, okay, they are to draw, assemble, test, and describe the operation of a single double-acting hydraulic cylinder in extension, retraction, and stop position. So that's one. You use hydraulic cylinder. And number 2, similarly, to draw, assemble, test, and describe, but now you are using a single 2-directional hydraulic motors in 2 rotation direction. So it's very basic. You will create a circuit, a complete circuit of hydraulic system. One using the cylinder, another one is using the motor. So they give you the procedure, how you can do it. Okay. So this is apparatus lah. Kalau dalam lab we see lah what is the power unit, pressure relief valve, pressure gauge. So all of the apparatus you will use in your software. Okay, you will have to find your the components in the software and make a circuit, complete circuit. Okay, the procedure. So using your Festo software, so we will draw the relevant hydraulic circuit on Atomic Studio. This is software lah, the Festo tu, and test the circuit using the simulated function. And after you draw complete circuit, you can run the circuit and test, tengok how they in the simulation, how they move, how they working. Okay, assemble the circuit you have drawn in Atomic Studio on the hydraulic trainer. So ni if you in the lab, so we can do it the real circuit lah. But now we are not in the lab. We just draw in the software and run through the software. Okay, test your assemble your assemble circuit to show that it is fully functional. Before testing, please consult your lab supervisor. So similarly, this number 4 also we did it. So let me if we are in the lab, so we can do this number 3 and number 4 if we are in the lab, but now we are not in the lab, so number 3 and 4 we can ignore lah. Number 5, write a report on what you have done. So after that, after you complete drawing the circuit, you tested in the simulation, and if we have the real one, test the real one in the lab, then you write a report on what you have done. Okay, but for now we are only focusing on 1, 2, okay, 1, 2 and 5 lah. 3 and 4 ni we cannot do, we cannot assemble the circuit in the lab, we cannot test the circuit, so we just test it, assemble it, test it in the software. Okay, so they are not here. In this practical assignment, you must produce 2 hydraulic circuit, like we said here, there are 2, one using a hydraulic cylinder, another one using the hydraulic motors. Okay, one is circuit to control the operating cylinder, and another one to control a single 2-directional hydraulic motor. So discuss with your lab supervisor and how to safely perform the task. So we're not doing anything, we're just doing the software. Okay, so this is the circuit that are given to you, the schematic circuit. Okay, there are the hydraulic cylinder, there are the DCV, directional control valve, there are pressure relief valve, there are pump, there are filters, and the tank or reservoir. Okay, so in this diagram, I noticed there are, when you draw the circuit in your software, just follow all of these components lah. It's similar components, but for the DCV, this spring return, there is 3 push button and spring return kan. So this spring return is wrong. There are shouldn't be a spring return. You should put all push button. One push button on the left and another push button on the right. Okay. So when you draw your circuit for your DCV, choose the edit your DCV with both push button on both sides. Okay, I will show you how we can do this. Okay, so remember not using the spring return. Okay, and then the next procedure, assemble the hydraulic circuit is shown in figure. Okay, you can use your software to assemble this circuit according to the step. Connect import of the directional valve, the DCV, to pressure manifold. Okay, this. Connect port A to the cylinder to this cylinder, and B to the end cylinder, and then the tank of the DCV to the reservoir, to the T the T yang kat DCV ni ada T juga kan. That T will go to the tank. This is the tank. So that's how you do it, and then you can shift the DCV push button, one push button on the left and one push button on the right, to see how they and observe the cylinder extension and retraction. So when you push button one side, they will go to extend, and then when you push another button, and then you go to retract. Okay, so you will see that in your software lah. So similarly, in the second circuit, all this the same, just that you change this cylinder to motor, using a motor. Okay, that's the difference lah. Okay, but the rest is the same. Okay, so when you, let me show you, so that after that you can do it by your group. Can you see my software now?
Yes, sir.
Okay.
Yes, sir.
So this is your software.
Yes, sir.
This is your software. You open your fluid sim hydraulic, because we are doing the hydraulic components now. So open your fluid sim hydraulic. So on the left column, you have all your components. On the right column, you will open your circuit lah, where you draw the circuit in this column. Okay, how you open this column, you just open from here lah. Okay, just press new, and then you will have your new project lah here. So you want to do draw a circuit. Okay, so in the first circuit, there are a tank. So you just drag all your components inside this column, so that you have one component tank. You can make it bigger or smaller, up to you. Okay, so this is the tank. And then you have in that picture you have a filter, kan? Okay, then you can put your filter. Okay, you can change this orientation of the filter if you want, like similar to the diagram, so that we can follow all the lab sheet, similar like sheet. So this is the tank, this is a filter. After the filter, you have I think pump. Okay, sorry. Okay, pump. Yes, sure. Right. So where is your pump? It's here. Okay, so you drag your pump, put your pump. Okay. After the pump, what else? Can someone?
Pressure relief.
Pressure relief, Okay, find your pressure relief. Pressure relief. Oh, this one. Is it? Display control. Okay, pressure relief valve. Okay. Sorry. Okay, after that, what else?
DCV.
DCV. It's a 4-3, kan?
Yes, 4-3.
4-3, So I think this is 4-3. Oh, this is 4-3. Ni hand. Short of position. Oh, sama je. Okay, we just take one. Okay, that's here that like I mentioned to you. You should put all push button on both sides, left and right. Okay, how you do it? You right click on this component, and you can have properties. Okay, so you have these properties. So one right and one left. Like I said to you, you should put all both sides push button. So you find push button, and this one. Okay, and for the right as well, push button. Okay, so that you have 4-3 ways push button, both sides. Okay, so that's your DCV, and last we should have the cylinder.
Yes, sir.
Cylinder, mana cylinder? Oh ni, okay. This is double atom cylinder. Single atom cylinder. So you need double atom cylinder, so that they can expand and retract. Expand and retract. Okay. So you have all of your components, I think. Or I think we should have another tank kat sini dalam cylinder tu. There are 2 tank I think yes. Let me check. 1 and 2 and 3. Okay. Even though there are 3 tanks in this diagram, it doesn't mean that. Oh, sorry. Doesn't mean that you have 3 different tanks. This is not that what it means. It means like why you should put 3 tanks in the diagram. Is that where it goes, where it goes after that. After each, is only 1 tank. Okay, don't confuse. It's only 1 tank. So it should be whenever they go out from the tank, go to the filter, pump, or whatever, and then they come back to the tank. Okay, so that's what it means. So it's just to tell you where it goes after that. But it should be the similar tank lah. So in the diagram we draw like that, but in real circuit, when you do in your lab, we are connecting the hose back to the tank, the similar tank, not the different tank. Okay, so we just put the tank here in this lab, in the circuit. So 1 tank and another tank from the pressure go to the tank, and the CV as well go to the tank. So this means all after that they go to the tank, to the same tank, not different tank. So we just put there to tell us where it goes after that. Okay, so there are another one after the tank. Kat sini. Dah 3 dah. Okay, you can delete it. So 1, 2, 3 Okay. Okay, now you can connect the dots lah. I mean, in real life, using the hose using the hose to connect all of these components. So you just drag it to this. So you connect the tank to the filter, and to the filter to the pump, and to the pump to the P. Okay, because you are going from P to wherever lah, A or B, and then A to be T and go to the tank. So A go to the A to expand, and B go to back here, and let it retract, and this tank and this T after that the fluid go to the tank again. Okay, and this P and this pressure relief valve. Okay, you can connect to the line so that it can give some pressure, and this tank go back, this T go back to the tank. Okay, so this is a complete circuit lah, complete circuit of for the lab 3. So you have a complete circuit. You have the hydraulic cylinders, you have the DCV, you have the pressure relief valve, you have the pump, you have the filter, and you have the tank, the reservoir. After that, you can run lah. You can run and see how it simulates. So what you do is you just click the run button. Okay, and so this is where it should go, and you can push one button, and then you can see the cylinders expand, and then you have another button here. Now when you push again, and then the cylinders go back to retract. Okay, and this is the normal position, and you click again, and you need to hold. You click, you need to hold. The cylinder will expand. You click again the button to the normal position, then you push the button, and the cylinders go back to retract back. Okay, so that's how you do this lab lah. Okay, but let me show you this thing, the reservoir, filter, pump, and pressure relief valve. Okay, these 4 components. Okay, it can be simplified by using this pump unit. You see, it show you it's a simplified representation. So this triangle, one triangle here, is already represent for this reservoir, filter, pump, and pressure relief valve. So if you delete all of these components, okay, and you just use this thing, simplified pump unit, you connect the dot, you still can run it. You still can run it. Okay, press button again. Okay, see, it's just a similar thing, but I mean in the industrial, maybe they just put a simplified so that they don't have to draw all of this. But for our purpose, for the sake of learning, so I suggest you to follow the lab sheet lah. Okay, draw all these tank, the filters, the pump, so that you know how what is the component goes to the circuit. Okay, but I just show you here so that maybe in the future you see this symbol, and it's just the same lah. Okay, it's just a simplified representation of the component, the 4 components. Okay, all right. So for your next the number 2 circuit, you just change the cylinders to the motor lah. Okay, just choose the motor, and then change it to the motor. Okay, anyone to ada soalan, any question on this, how you can draw the circuit?
Sir,
Yes.
yang untuk motor tu, dalam diagram dia untuk spring tapi letak push button lah.
Yang mana? Dalam mana? Dalam lab sheet ni?
Dia untuk yang motor tu, dia letak spring juga belah kanan tu. So nak tukar jadi push button jugalah.
Yang ni Oh, yang nombor 2
Ah,
betul betul betul. You can try put first spring button and see what it happens. If you got an error, that means you cannot put spring button lah. I did not make the circuit yet. You can try it. Try using the similar push button and spring button and see when you simulate it whether it can goes or there is an error. If there's an error, that means you need to put double push button lah.
okay.
Okay, you just try. You just play around with the circuit. You can change the apa? Just for sake of learning, you can change the DCV to 42 apa? Ada banyak 42 and see what happens You can use lever ke Try just play around. But for the lap sheet, just using this 43 DCV and double push button here. Okay?
Okay, thank you.
Alright. Say anything before I left to you.
Sir,
Yes.
yang saya nak tengok yang lab 1 tadi sir. Yang
ni lap sheet. Okay, okay. Kat mana? Apa?
Yang tadi tu yang sir tukar kiri kanan tu kat mana sir?
Kiri
Yang
kanan.
dekat-
Oh, okay.
Ha.
Ni
Ha.
So you can click your component
Okay.
and then right click. And then you go to properties. So you can change.
Oh.
Okay, so this is left actuation. Spring return ke, pilot ke, manual ke, apa ke, you can choose. This is for right. Okay.
Okay sir.
So semua komponen lain kalau awak nak tukar apa benda, awak just right click, you can have your properties. Okay. So click the
Sir.
component and double click, right click.
Yang dekat lab sheet tadi dia ada perkataan bar tu sir.
Oh ni gauge ni.
Gauge. Gauge
So
Kalau
this is
dekat
the gauge lah.
ha.
So you can put that not really significant. You can, I think there is a component there. Mana? Dia pressure gauge. I think I saw it before. Ni kot ni lah. Dia the gauge bar, so you can put your this. You can apa? Connect this to your pressure lah, but doesn't affect any. It just for tells you how many bars in this pressure relief valve.
Oh.
Okay. Maybe if you in apa advanced circuit, maybe you want to change that. You want the numbers in the pressure relief valve. How many? 2, 4, 5. But in this lab sheet, they are not asking you to change the pressure. Just only apa tak dinyatakan lah. So you don't need to put this pressure gauge. So but you want to put, you can put, not a problem. Okay, so that's the pressure relief, just gauge lah, pressure gauge. Okay.
Thank you sir.
Alright. Anything else before I leave it to your group to do it, to play? Okay, so after you done this, play with your software. So you need to write a report lah. Okay. So this report should be longer than lab 1 and 2 because it's not really not like just a basic component. You need to explain how this circuit working. So you need to explain lah the fluids working whenever you push the button, the fluids go through from the reservoir through the pump and go to the port P and go to the port A and then the cylinders expand. And then when you push the button again, the cylinder retract and the fluid goes from B to T and goes to the bank to the tank. So that need to be right in your report. Okay, in your description how this fluid working, so that we know you understand how the fluid is working, how the fluid how the system is in the fluid in the system working, where it should go first. So that's what you need to write in your report. Okay. Alright. Okay. If you don't have any question, okay. So for those who just joining, please fill up the form, okay, the attendance form, and so I'll give it to you on your group, by your group, like previously. Do your meeting by your group. You can discuss together. But I think I suggest you draw by yourself lah. All of you try draw the circuit in the software and simulate the circuit whether it goes well or not. And then in the report you can write the report lah. So just one report, your group report. But for your learning, I think you should also try to write it by individual. But when you submit to me, just one for group, okay. But for the sake, I don't want just only one type the report, and it's only him lah or her that learning and how this circuit's working. So that's why I suggest all of you do the report individually, just because of learning, right, where this fluid goes through or whatever. But you discuss among yourself, and then just submit to me only one report. Okay, understand?
Yes, sir.
Yes, sir.
Yeah, boleh So I leave it to you, and we can meet again maybe 9:40 or 9:35. Okay, in this meet. Okay, so I leave it to you, to your leader, to make a meeting, and you can discuss together. All right, have fun.